Good afternoon to all, respected teacher. Myself Bisal Sinha, a student of Coachbihar Government Engineering College from the Department of Electronics Communication Engineering, third year, fifth semester, and my roll number is 34900032314. Today, I am going to present my CA1 presentation on the topic Digital Communication in Stochastic. So let's start. Pulse coded modulation. In analog modulation, we can modulate either a continuous or a carrier or pulse carrier by the input analog signal. The former is called CW modulation and the latter is known as pulse modulation. Pulse modulation technique like pulse amplitude modulation, PAM, pulse width modulation, PWM, or pulse position modulation are analog modulation techniques as the amplitude, width, frequency or position phase of the transmitter carrier pulse vary continuously in accordance with the variation of the input signal. Multiplying the carrier pulse with the input signal also frequently translate the spectrum of the input signal, thereby giving rise to pulse modulation. Actually, a pulse modulated signal contains the sample value of the source signal in any of the following three parameters of the carrier pulse, either amplitude or frequency or phase. However, these samples values are not quantized, so these modulation terms are known as analog modulation. Now, if a palm signal is first quantized and then converted to a digital code, we get a complete digital signal. This signal is called pulse coded modulated signal, and the process is known as pulse coded modulation, PCM. The advantage of PCM over analog pulse modulation method is that in PCM, the information does not lie in any property of the pulse waveform. Rather, it lies in the presence or absence of the pulse, or to his side of the threshold value the pulse amplitude lies. Thus, the noise immunity of a PCM signal is much more than any analog modulated signal. Therefore, PCM can be used for storage purpose, example CD recordings, hard disks, where the noise immunity of the signal is important. PCM can also be used for baseband transmission of the signal. In such cases, the code bridge needs to be converted to pulse waveform. Before learning about PCM, we first know is what is sampling and quantization. Sampling theorem states that a signal band limit to FM Hz having no frequency higher than FM Hz can be completely reconstructed by sample if samples are taken at the rate of interval Ts 1 to the power 2 FM second or at the rate of Fs greater than equal to 2 FM. What is quantization? The quantization of analog signal is done by discreting the signal with several quantization levels. Quantization represents simple values of the amplitude by a finite set of levels, which means converting a continuous amplitude sample into discrete amplitude signal. Now let us see some diagram of quantization level. This is a diagram of the modulated signal which is given like D1, D2, D3, D4, D5 are Division boundaries, and L1, L2, L3, L4 are quantization level or representation level. So this is where we quantize a sample or signal. PCM. In the transmitter portion of a PCM system, the input analog source signal is first sampled by the sampler. The cis circuit is simpler emitter follower. In the absence of the clock signal, the output follows the input. The analog signal is applied as the input signal. Another input to the base of the transistor is a clock signal. The frequency of the clock is chosen as a desired sampling frequency. The amplitude of the clock signal is chosen that the high level is at 0 volt and the low level at some negative voltage, which is sufficient to bring the transistor to cutoff for the full range of values of the input analog signal. When the clock is on, the transistor is also on and the circuit behaves as emitter follower. So the output follows the input signal. When the clock is off, the transistor is also cut off and the output is absent. Thus, we get a sample version of the input signal. Key steps in PCM is a method used to digitally represent analog signal. In PCM, analog signals such as sound waves is sampled at regular intervals, and each sample is quantized to the nearest value within a range of digital steps. These values are then encoded into binary form. PCM is widely used in digital audio like telephony, digital communication. Key steps in PCM: sampling, measuring the amplitude of analog signal at regular intervals, quantization, approximately each sample to the nearest fixed values, encoding, converting quantized value into binary format. The block diagram of PCM is as follows, followed by transmitter in the A portion and receiver at the B portion, where transmitter consists of sampler, then quantizer, then encoder, and receiver consists of quantizer, decoder, holding circuit, and low passing filter. Encoder. The process of assigning digital data bits to different quantization level is called encoder. If there are L number of label, n bits are sufficient for encoding process, where L is equal to 2n. We have n bits corresponding for each sample, then we can unite bit rate. RB is equal to n into Fs, where n is equal to number of bits per sample, Fs is equal to samples per second, RB is equal to bit by sample into sample by second, which is equal to bit by second. According to the block diagram of PCM, in the transmitter portion of a PCM system, the input and source is first sample, the sample circuit as follows. This decoder output is a sequence of quantized pulses. The pulses can be given to a holding circuit followed by a LPF to construct the transmitter along signal. These sample pulses are then quantized in the quantizer. In a typical PCM system for a voice telephony application, either a MULO or ALO commander is used. In this encoder that then encodes these quantized pulses following a particular coding algorithm. These coding algorithms are fairly general and readers are likely familiar with them in digital circuit courses. For example, binary code, gray code, BCD or any other code can be used. The digital communication receiver receives the pulses contributed with noise as well as interference from other signal in the communication link. After doing some processing, which when the signal is to be decoded, receiver gives it to receiver portion of the PCM block. The first to receive these noisy pulses in this block is again in quantizer, but this quantizer is different from the transmitter quantizer because it has to take decision about the presence or absence of a pulse transmitter, because hence this quantizer is basically a threshold detector and in most cases a bipolar to unipolar converter with two quantization levels. The quantization binary value signal now goes to LPF converter that decodes this signal. This decoder output is a sequence of quantized pulses converter that decodes the digital signal. These pulses are then given by a holding circuit by LPF to reconfigure a traditional analog signal. The holding circuit may be zero order holding, which is natural but as a switch. Opening and a closing to a capacitor. PCM word size. A natural question that comes to one's mind in how many bits shall the PCM encoder assign to each analog sample. For digital telephone channels, each sample is PCM encoded using 8 bits, yielding 2 to the power 8 or 256 labels per sample. The choice of the sample levels of the bits per sample depends on how much quantization noise we are willing to tolerate with the PCM format. Let a magnitude of the quantization level error UQ be specified as fraction P of the peak to peak analog voltage BPP as follows. EQ module in mod is less than or equal to PPPV, since the quantization can be more than half of the steps and we already related to the step size to peak voltage and number of quantization levels. BPP is by 2L is less than or equal to PPV. Introducing the word size L in this equation, we get for binary PCM 2 to the power L is equal to L greater than or equal to 1 by 2 pp. Finally, the relation between the quantization level is obtained. L is greater than or equal to log to the power 1 by 2p. One should not be confuse the PCM word size, the memory signaling concept of the transmitting k data bits per symbol. The following example clears by the point. PCM bandwidth. To find the bandwidth of any signal, we need to find this frequency domain representation. As already mentioned, PCM signal is quantized and encoded pulse amplitude modulated signal. It's natural to derive the PCM spectrum of palm spectrum. However, the process of encoding is a nonlinear operation which makes the spectral determination of PCM signal by this method quite complicated. In a system like PCM where all these degradations are present, the best strategy to analyze each degradation separately in the absence of all other and then combine them together, taking it to the account mutual interaction between them. With this goal in mind, we derive the next ratio signal power to SNR of PCM, which only quantization noise is present. In such cases, reconciliation signal receiver can be written MT is equal to MT by EQT. Noise in PCM system. As in any other baseband communication system, there are several sources of noise and interference in a PCM system. This should be described in section 5.1. For the present, we only mention present typical system aliasing noise, quantization noise, channel noise and intersymbol interference. Aliasing noise comes due to improper sampling, and since its values is completely known for the specification of the quantizer, it can be easily tackled. The next cause of degradation is channel noise, which occurs outside the transmitter and cannot follow any determination process. It should be modeled with the help of statistical consideration. The last cause of degradation is not noise but an interface called inter-symbol interference ISI, which comes into existence because of the high data transmission rate compared to the time response of the electronic system, comparing the transmitter, receiver and the channel, this being predictable by the knowledge of the transmitter and receiver characteristics. One can employ methods to combat ISI. Differential PCM. In a differential PCM, instead of encoding each sample, the difference between previous and present samples are encoded. This will reduce the overall bit rate and number of bits required to transmit one sample. If we have higher correlation between samples, then we would further reduce number of bits and quantization error by using a predictor and quantizing the difference between the actual value and predicted value. Predicted value would even be closer to actual value than previous value which we use in PCM. Thank you so much, sir, for giving us the opportunity to present our presentation, and we would likely be highly obliged for the grand opportunity, and my presentation ends here. Thank you very much.